Good morning, everybody. My name is Irene Chiesa and I am a PhD student at the University of Pisa in Italy. Today, I will talk to you about the development of sutureless clips for intestinal anastomosis. Nowadays, manual suturing is the current gold standard for intestinal anastomosis. It is a technically challenging and time-consuming procedure that requires a learning path for the surgeons. In addition, it has a high probability to failure that can also lead to the death of the patient. In order to overcome these issues, we developed and fabricated smart sutureless clips for intestinal anastomosis. The rationale of our device relies on the negative expansion coefficient of regenerated silk. To fabricate this innovative device, we exploited 4D printing. 4D printing is an emerging and innovative fabrication technology that denotes the fabrication via additive manufacturing of structures with the capability to shape-transform over time in a programmable way and under the application of external stimuli. Our device is made of a bilayer alloy tube comprising a first layer of PHPV and a second layer of seed compound. Two different seed compounds were explored. The first one comprises calcium chloride, where in the second one both calcium chloride and potassium nitrate were added. The device was fabricated via extrusion-based 4D printing, equipping the printer with a rotating spindle. Here there are some photos of the developed devices with different generated seed compound. Microscopic images revealed the bilayer structure of the device with a thickness of around 50 microns. Then, finite element modeling were performed in COMSOL multiphysics in order to analyze the capability of the developed tube to contract under thermal stimuli and compress the intestine wall. The rationale of our device relies on the negative thermal expansion coefficient of regenerated silk that is higher in modulus if compared to the one of PHPV. In addition, when potassium nitrite is added to the solution, the Young modulus of the regenerated silk increased and overcome the one of PHPV. The models reveal that the tube is able to contract and compress the intestine wall when the temperature moves from the room temperature to 37 degrees, that is the temperature inside the human body. In addition to that, in accordance with the results of tear and mechanical tests, when potassium nitrate is added to the solution, the compression is higher. Finally, ex vivo tests were performed on a porcine intestine, comparing the birth impression of a pristine intestine, a conventionally sutured intestine, and intestine sealed with our device. As you can see from this slide, the birth impression of an intestine sutured with our device increased if compared with the one of conventionally sutured intestine and is comparable with the pristine one. To conclude, in this study, bilayer tubes made of HBV and regenerated silk were successfully fabricated by extrusion-based 4D printing. The addition of potassium nitrate to the solution promotes the formation of beta sheets, thus stabilizing the structure and enhancing its resistance to collapse. Finite element simulation and ex vivo tests were performed and proved the potential of the developed 4D printed bilayer tube as a bio-based device for intestinal anastomosis. In the future, in vivo tests will be performed in a murine model to test the capability of the device in vivo. And in addition, complex regenerated silk pattern deposition will be explored in order to maximize the compression behavior. These studies was partially financed by the Italian Ministry of Education under the PRIM project vision. I thank you for your attention and I will be glad to answer all your questions.